So today, all we are looking at is domain of our functions, because this is like an extra piece to being able to do our combinations and our compositions. So combinations will be adding, subtracting, multiplying, dividing. Compositions will be taking one function and putting it into the other. In order to be able to do either of those things, we have to understand when our functions are allowed to exist. So there are two times when domains are restricted. So if neither of these things happen, your domain is going to be all real numbers from negative infinity to positive infinity. If you have an even root, so that's going to be a square root for us, we cannot take the square root of numbers less than 0. So we cannot take the square root of negative numbers.
Wait, so Miss Nash? I mean, not.
Yes.
So you cannot take the square root of negative numbers.
Yes.
Okay, just making sense.
So when we were back doing complex numbers, we took the square roots of negatives and we turned them into i's. We're not going to deal with that today. So just we can't take the square root of negative numbers, and then we also cannot divide by 0. Yes. So can't take the square root of negative numbers. We cannot divide by zeros. Those are the two things that we can't do. Everything else we can do. So we have to look at a function and we have to say, are there any square roots? Are there any negatives we're going to divide by? Or are there any square roots, and are we dividing by any x's? So this first one here, there's no square roots. It's not a fraction, which means we're never going to divide by 0. So our domain on this one is negative infinity to positive infinity, because there are no restrictions to what we can plug in. So if neither of these things happen, our domain is just negative infinity to positive infinity.
Wait, why is that?
Because there's no square roots and there's no x's in the denominator.
Dude, were you even listening?
No, that's why I asked.
I'm about to swear.
Exhausting.
I'm so sorry. You know what's so funny? I don't act like this in any other class. Actually, that's not true. I act like this in Ms. Nelson's class.
You know what's funny?
So you said there's
None
no
of that
square
is
roots and no.
Yes, because there's no square roots or fractions.
What?
Okay,
Your pants. They're from the Christmas story.
this next one. We've got 3x plus 2 over x squared minus 2x minus 3. So this one, we don't have any square roots, so we don't need to worry about that. But we do have a fraction, and we are not allowed to divide by 0. So anytime we have an x in the denominator, we have to figure out when the denominator is going to equal 0, because we're not allowed to divide by 0. So in this one, we've got x squared minus 2x minus 3. We need to figure out when that equals 0, because it cannot equal 0. In order to do that, we are going to factor. So we need to find the two numbers that multiply to negative 3 and add to negative 2. So that's going to be 1 and 3. And we need to make one of them negative in order to multiply to a negative. I should zoom into this. We want to add to be negative 2, so we want to make the big one negative. So this is going to be x minus 3 and x plus 1. So all I've done is I factored out my denominator, which we've done when we were doing rationals, and I asked you to find the restrictions. The restrictions are the points when your domain can't exist. So we've got x plus 1 and x minus 3. We're going to set each of those not equal to 0. So x plus 1 can't equal 0 when x equals -1. X minus 3 cannot equal 0. That's going to happen when x equals +3. So basically what we've done is the same thing we did with our rational equations, where we now know that x cannot equal -1 or 3. The difference, though, is that we are going to write this in interval notation. So that means we need to go from -infinity all the way to +infinity, but we have to exclude these values. So how we do that is we go from left to right. So like I'm pointing that way because I'm looking literally at a number line. So we go from left to right. We're going to go from -infinity all the way to up to -1. And then we have a break in what our domain can be. We are going to use a parentheses because we cannot be -1. So parentheses mean you cannot be that number. A bracket means you would be that number. Then I'm going to put a U. That's a union symbol. And I'm going to do another little chunk from -1 to +3. Because I can be any numbers in between those. But I can't be 3. So I'm going to do another union symbol. And then I can go from 3 to +infinity. And this would be my domain. So what this means is -infinity to +infinity, except for not -1 and not +3. So -infinity up to -1, stop. -1 to 3, stop. 3 to infinity. Hello. Where am I? There you go. Thank you. Okay. Any questions about that one? Okay. Next one we've got h of x equals the square root of 3x plus 12. So what's inside this square root has to be greater than 0. It can be equal to 0, so it has to be greater than or equal to 0. I know words. So we're going to take what's underneath that square root, 3x plus 12. We're going to set it greater than or equal to 0 and solve that. So we'll subtract 12 from both sides. 3x is greater than or equal to 0 minus 12 is -12. And then I divide both sides by 3. I get x is greater than or equal to -4. Okay. To write this one in interval notation, it's not that we just can't equal -4. We can't be smaller than -4 either. So instead of going from -infinity to +infinity, this one's only going to go from -4 up to infinity. But we're allowed to be -4 because we're allowed to be 0 here underneath the square root. That's okay. So for this one, we are going to use a bracket with our -4 up to +infinity. So that would be our interval notation. It's from -4 to +infinity. Any questions on that one? Okay. Last one. We've got a square root in the denominator. So for this one, 14 minus 2x has to be greater than or equal to 0 because we cannot take the square root of a negative number. But also, this whole thing, the square root of 14 minus 2x, cannot equal 0 because we can't divide by 0. So for this one, instead of just being greater than or equal to 0, we have to be greater than 0 because we're not allowed to be equal to 0 because the square root's in the denominator. So it's going to be 14 minus 2x has to be greater than 0 instead of just greater than or equal to. This is us combining together the two things that we can't do. We can't divide by 0. We can't take the square root of a negative. So for this one, I'll subtract 14 from both sides. I'll get negative 2x is greater than negative 14. And then I will divide both sides by negative 2. And I'll get x. Quick quiz question, what do I need to do? You need to flip your sign because you just divided by a negative. So I get x is less than negative 14 divided by negative 2, 7. When we multiply or divide by a negative and an inequality, we need to flip our sign. So that means x has to be less than 7. So for this one, if we're doing less than 7, that would be from negative infinity up to 7. So our interval notation would be from negative infinity up to 7. But we cannot be equal to 7, so we use a parentheses, not a bracket. Okay. If you want to put a note to yourself of parentheses and brackets, because I know that'll throw people off, you use parentheses if you are excluding the number and for infinities, because we always technically exclude infinities because we can never reach all the way to infinity, so we can never like grasp infinity, so we can never include infinity. And you use brackets if it's included. So we used a bracket here because it was okay to be negative 4 because it was greater than or equal to negative 4. And then we used parentheses here because we were excluding those values. And we used parentheses here because we couldn't be exactly equal to 7. Cool. What's up? Parentheses for excluded numbers and infinities. And then brackets for included numbers. I didn't put a number sign yet. What's up? Yeah. So just that bottom there. Okay. Okay. Your assignment is on Math Excel. It is just domain. I think the first couple, I know the first one is negative infinity to positive infinity. So we've only got 15 days left this semester. A lot of us have been doing a fall behind and play catch-up game the entire semester. We have to cut that right now because after the 16th, you won't be able to play catch-up anymore because the semester is over. So go ahead and get to work. Let me know if you have any questions. Actually work today, please.